environmental science educator for the Cahaba River Society.
And I'm Randy Haddock, also on staff with the Cahaba River Society.
I'm Gordon Black, Education Director at the Society. We're standing here today in the Little Cahaba River. This is one of the sites we use most often for our field trips. We're going to show you a little bit about one of those trips today.
We're doing a survey of aquatic macroinvertebrates. So, what are they? Why are we interested in them? And how do we do it?
We're going to refer to this ID sheet several times during this activity. We use this to help us learn about each one of these creatures that we find. It doesn't contain every single creature we might find out here that fits the description aquatic macroinvertebrate, but many of the most common ones are here. If you would like to do an assessment of your own small stream, or if you can get to the river and would like to do an assessment like we're going to do today, you can download a copy of this from our website, cahabariversociety.org, and look under Resource Library. We'll have the ID sheet for you there.
They are really described by their name. They're all aquatic. They live in the water. They are macros, which means we can see them with our eyes without magnification. Some of them are really small, some of them are quite large. A magnifying glass might help you see details on some of the little ones, but you can see all of them with just your regular eye. And they're invertebrates, which means they have no internal skeletons. Now, this is not just one thing. This is a lot of different creatures. This is a wide variety of animals that live out here. Some are nymph and larval forms of insects. These insects are of many different kinds. Most of the insects are youth, babies, and as they mature and get older, they go through metamorphosis. They become flying insects in many cases, not all, but most. There are other creatures besides insects, though. There's things that we might call bugs that really aren't insects. There are crayfish, there are mussels, there are snails, aquatic snails that live out here. So lots and lots of different things. We call this biodiversity, and that really tells us a lot. I'm going to talk more about that. The reason that we're so interested in these is because they inform us as to the health of the habitat and the water quality, how clean the water is. Some of these creatures can only live in water that is very clean, that has a lot of dissolved oxygen in it. We consider these species indicator species because they do indicate the water quality. Why is that important to us? Well, several reasons. From a scientific standpoint, this river is one of the most amazing rivers on Earth. That biodiversity I just spoke of is at an incredibly high level. There are a lot of different kinds of plant and animal out here. Really more per mile than just about any other river in North America. So scientists love coming here to study all this biodiversity. From a recreational standpoint, this river is magnificent. Whether you're coming out here to watch the birds, enjoy the beauty, go fishing, boating, kayaking, swimming, or just relaxing and enjoying it, this is one of the best places anywhere. Anytime people come out here and spend time on the Cahaba, they always vow to come back and do it again because it is so rewarding. But probably the most important reason we're concerned with water quality here is because this river supplies a great deal of the Birmingham area drinking water. There's lots of sources around for water, but the cleaner the water you get, the cleaner the source, the less it costs us to make it pure, clean, potable, ready to send out to our houses. So this river is extremely clean to start with, a perfect source for the Birmingham Water Works to get our drinking water from. Now, how are we going to do this? We're going to show you in a few minutes exactly what we do, but the nutshell is we break up into groups of 2 or 3 when we're doing our field trips. We walk around with a small container. That might be an ice cube tray, it might be a square plastic bucket, something that allows us to gather up creatures and hold them.
We're out here to do a water quality assessment by looking for aquatic macroinvertebrates. We like using these ice trays because the animals show up better with the white background. Make sure there's water in the tray because these animals get their oxygen from water, just like we get our oxygen from air. So the way we're going to do this is you're going to have your wonderful, nice macroinvertebrate sorting device. Our devices were made by NASA, sent over by the government. No, I'm just kidding. This is a regular ice tray. So what you need to do is you need to fill it up with water because once again, these are aquatic macroinvertebrates, so they need water. So you want to fill up your tray with clear, clean water. Now, if you fill it all the way up and put macros in here, those macros may get out. So you want to pour a little bit of your water out, but you still want to have some in here. So this is about half in each cube. So this is what you need. So when you're looking for macros, you can find a rock, you can find a log, something that you can pick up. So we're looking for these macros. You're going to find a rock, turn it over, and the reason why you're picking it up and turning it over is because these macros are hiding. If they were on top of the rock or log, they would be fish food. So you want to turn it over, look very closely, and I have something right here. Looks like a flatworm. So you want to take your finger and be very gentle. Just wipe it off, and you want to put it in your tray.
This is all the algae that's kind of green. On the bottom side, it's not so green. It's all dark colored. And I'll point out here, on the edge are a whole bunch of diptera, fly larvae. So not just the top and the bottom is a different habitat, but the edge is a different habitat. So there are a bunch of critters that are already adapted to living in specific micro habitats, if you will. And that's why we want to put it back the way we found it. If we put this rock back with this surface down, well, this is going to take time to grow a whole new complement of algae, and the algae down here is going to die. So rather than waiting for that to happen, we'll put it back the way it was, so it continues as.
Oh, there's a water penny.
There's a little water penny going. He's booking for. He's wanting to get on the bottom side of the rock, and that's what he's going to do. Unless I turn this around and put it back. So that's the top, and that's the bottom. Put it back the way we got it.
As you guys see, I'm holding a chart. Right here, this doesn't have all of the cool stuff that you can find, but this is the most common things that you can find in your river. So it's in 3 groups. The top part is sensitive to pollution. This part here is moderately pollution tolerant, and over here is pollution tolerant. The species in group 1 need clean water with high levels of dissolved oxygen. It turns out clean water holds oxygen better than polluted water. These guys can withstand a little bit of pollution, and these guys can withstand a lot of pollution. So if you go out to your water source, if all you find are the species in group 3, that's an indication of a problem with water quality. But if you can find some of all 3, that means that everything is good, because these guys can only withstand certain amounts of that. So in group 1, I believe that we have found some critters, and I'm going to show you some. I'm going to point to them on the chart, and I'm going to bring them out of my wonderful trays to show you guys. These are our wonderful flat-headed mayflies, and if you look really closely, you can see those gills fluttering. See those gills on its backside? These snails are endemic, very often found in large numbers. There are 2 groups of snails found on our chart. Gilled snails in group 1 and pouch snails in group 3. The gilled snails in group 1 breathe water. The pouch snails in group 3 come to the surface and breathes air. When you aim the pointy end of the snail at the sky and turn the snail so that the aperture or the opening is facing you, if the aperture is on your right side when you are looking at it, it is a gilled snail. If it is on your left, it's a pouch snail.
Caddisflies were the first bugs to invent silk. And here's a caddisfly that's built a little silken net, and you can, I don't know if you can see him on the inside of the net. He's feeding on the surface of the silk that has captured little food particles that have been carried down in the current and got caught in this little net. So he's in there wiggling around, feeding on the algae and organic matter that's been trapped in his little silken net. Well, then we'll start with the water penny. This is a little brown flat beetle larva. You can see them walking around there. They're very streamlined. They have a little hump, and so the water can flow very rapidly over their bodies, and they like fast moving water, and they have little bitty tiny gills, so they need good oxygen in the water for those gills to be adequate. And then here we got a couple of stoneflies, which are also good indicators of good water quality. A while ago they were doing little push-ups. They have little gill tufts underneath their armpits, and that's not a lot of gill surface, so that demands that they live in water that has really good dissolved oxygen. And if you'll watch him there for a second, he's doing push-ups to help ventilate and move freshly oxygenated water over his gills.
As we move into the moderately pollution tolerant group 2, we find some very interesting animals.
Here we have a couple of damselfly larvae. Damselfly are very closely related to dragonflies. You can see the head end and the tail end, and the tail end has these 3 feathery gills, which they wave around a little bit and get dissolved oxygen out of the water that way. They'll even use those gills to swim around a little bit.
Now we'll look at several species of dragonflies. These are in the same order as the damselflies and have many similarities, but they do have internal gill structures.
Now the next one on the chart is my favorite thing to find, a dragonfly nymph. Dragonflies live majority of their life in water.
This one you can see the wings of the dragonfly. This one's about ready to transform into an adult. When they're smaller, their little wing pads are almost invisible. They're small wing pads, but as the larvae gets bigger and bigger, the wing pads get a little bit bigger, and the next time this one sheds his skin, he'll probably do it by crawling out of the water and then becoming an adult.
And their wings are going to come out, and they're going to be silky and wet. They're going to wait till they dry, and as soon as they're dry, they're going to fly off.
I don't know if we've done this before, but the dragonflies have this lower lip that they shoot out with jaws on the end, and they grab their prey when this lower lip shoots out, and there's jaws on the end of that that they can grab and pull it back in and then munch on it.
Now we're looking at Hellgramites, which are Damselfly larvae. These are large, active predators. They need a lot of oxygen, so they have a lot of gill surface. You'll notice they look like they have lots and lots of legs, but they're insects with only 6 legs. Everything else are just sort of spines sticking off the side. When these do go through metamorphosis, they turn into large flying insects, a Damselfly. Very impressive. Look at these jaws on the front. These show you that it's a real predator.
And we have crayfish here.
There are about 100 species of crayfish in Alabama. 24 of them can be found in the Cahaba River.
Now, this guy right here is what I really want to show you. You see that blue looking thing right here swimming around? These are scuds. We call them amphipods. These are shrimp-like crustaceans.
We also found some isopods. These are like roly-polies or pill bugs that we find on land. These critters are omnivorous scavengers that mostly eat decaying plant matter.
And this little guy is called a Cranefly larva. And you can see on his tail end, he's got a little gill feature down there. Now these are not the most athletic little creatures in the world. They're just kind of a little grub. And what they do is wind up on a leaf pack. If there's like a limb or a root or something in the water, the leaves will kind of accumulate on that. And that's a good food source that these craneflies will exploit. They'll come get themselves on a little leaf pack like that, and they can just munch on the leaves and munch on the fungus and bacteria that grows on the leaves. And this one's about half grown or so, and he'll turn into a nice big cranefly, which if you can look that up, they look like a giant mosquito. They'll be sometimes over an inch long with a over an inch wingspan, and they as adults don't do much. They can be annoying, but they swim around, they fly around and then find a stream. Or there are different craneflies that live in your yard, so there are these similar kind of grubs that live in turf. So that's about what we've got here.
We found 2 creatures that are pollution tolerant enough to belong in group 3.
This guy right here is a flatworm. Planaria is what we call it. You can find those too. You see it wiggling around. Give it some more time to show you. Let me see if I touch it. Boom. There it goes.
Hi, I'm Ian Black. I'm an environmental educator at the Cahaba River Society. And this is an Asiatic freshwater clam. The scientific name is Corbicula fluminea. It comes from rivers and lakes in Southeast Asian countries like China, Japan, and Korea. But we're in Birmingham, Alabama, so what's a Southeast Asian clam doing here? Well, this is what's known as an invasive species. An invasive species is any plant or animal that is currently living in a location it's not native to. So what separates these mussels from the native ones living here in the river already? Well, for one thing, these are what are called hermaphrodites. What does that mean? Most animals are either male or female, and you need both in order to make babies. But these don't. These are male and female at the same time, and this one mussel can make babies all on its own. And it can do that really fast. One mussel can make thousands and thousands of babies every year and can fill a river before you even know it.
Now, let's do an overview. So in group 1, we found gill snails, water pennies, caddisflies, flat-headed mayflies, and I know they got this guy over there. So that is 1, 2, 3, 4, 5 from group 1.
We found 7 species from group 2.
Okay, and we only found 2 in group 3. Now, what is this telling you about your water quality? We found some of group 1, 2, and 3. Remember, everybody can live in a clean house, but let's say the house starts getting dirty. These guys will start to diminish. Their populations will start to decrease. These guys may last a little longer because they can withstand a little bit of pollution, but if it gets really, really, really dirty, these guys will be thriving. We want to see all these critters live together. So what this is telling us, that we found some in group 1, 2, and 3, is that our water is doing pretty good right now. So if you guys take pictures of what you found, please, 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 please send it to us. I want to see what you guys found. If you don't know what you guys found, we want to answer any questions that you have, and I would be so delighted to respond back to you guys, and so would my coworkers as well. So thank you guys for tuning in to this wonderful aquatic macroinvertebrate assessment.
And water quality can be assessed in a variety of ways. One of the nice things about the way Gordon and LaTanya do this exercise is that part of the day they do some water chemistry, another part of the day they look at fish diversity, and we've been talking about the macroinvertebrate diversity. And each one of those presents a different picture of how the river is, whether or not it's healthy. Water chemistry is kind of like a snapshot, a still photo of what the water is like right here and right now. And the macroinvertebrate diversity tells you a little bit about the life cycle of those bugs and the fact that they are healthy because they've had months and in some cases years of good water quality integrated over time. And if you find a good variety, that means that the water quality has been good for that entire time. And then, of course, fish diversity speaks to that water quality over time as well.
Thanks for joining us on this water quality assessment. If you have any questions, feel free to reach out to us at clean@cahabariversociety.org.